Please go ahead.
Yeah. So hello, everyone. Welcome to come back to the session. So this will be another new session, and we will have very interesting games to invite all of you to participate. Today, from now on, I will invite Mr. Shivasan from DCVMM to explain the dynamic of the game. Please.
Thank you, Wendy. So as everyone can see on screen, we will now be playing a short mind-stimulating game, and this game will be constructed of a quiz. This quiz will be facilitated using Slido. To join Slido, there are two methods. If you are joining us through the VFairs and event platform, on the right-hand side of your screen, there should be a Slido box. And if you move over to the poll section and input your name and click join and wait until the game starts, that will be one method of joining. The other method, if you would prefer, is to scan the QR code that is on screen at the moment, and your mobile phone or tablet will directly take you to the link where you can enter your name and click join. I will give members now 30 seconds to select a join option and monitor the joining progress.
Yeah, this will be a very exciting game, and please try, and any problem can please just feel free to contact our technical support.
Yes, thank you, Wendy.
You're welcome.
So the game will consist of 13 questions. When the quiz starts, multiple choice questions will appear on screen. Please select an answer and click the green send button to confirm your answer. You have 30 seconds for each question. Please be speedy as this is scored, and to get the highest score, you need to be quick. And please do keep record of your answers as it'll assist you in the following game. So I will now open the game and allow members to play.
Yeah. Are you ready?
Yes, I'm ready here, Wendy.
Yeah, maybe we just start.
So Edward Jenner coined the word vaccine from the Latin word vacca, which translates to which English word?
Wow. I guess everyone knows the history of the vaccine, maybe guessing the answer.
So we have a large majority saying cow. We'll now see the result, which is indeed correct. So
Turn
moving
to
on
maybe
to the
the
next
language. Yeah.
Microbiologist Maurice Hilleman, who developed over 40 vaccines during his career, demonstrated an early interest in science. At 13 years of age, he was spotted reading which book in church?
Haha, even
And
harder one. Difficult.
yes. In 2010, South Africa was the first African nation to host the FIFA World Cup. Zakumi, the tournament's official mascot, was what type of animal?
Oh. Just a small test to every participant. If you will be familiar with the history of the FIFA and South Africa.
This was a difficult one. So, which nation is entirely circled by South Africa?
Mhm.
The correct answer was Lesotho. Fifth question. Originally named by Italian navigators, which South American nation's name means made of silver in Italian? Seems everyone's quite knowledgeable on South American countries. The sixth question. During the 1854 cholera outbreak in London, Dr. John Snow's pioneering research led him to determine that the source of the contamination was a water pump on which street? Correct answer was Broad Street. The seventh question, the Coalition for Epidemic Preparedness Innovations, CEPI, who previously have done a presentation, was formally launched in 2017 at the World Economic Forum in Davos, Switzerland. Where is the organization's headquarters?
This should be an easy one. At least to me. Oh,
Oslo.
yeah, also.
The eighth question, which element is named after the Nobel-winning physicist? The correct answer is Rutherfordium, which everyone seems to have gotten. The ninth question, in the 1994 film Forrest Gump, which company did Forrest inadvertently invest in? The answer is indeed Apple. See, there are quite a lot of movie fans here. The 10th question, which female chemist won the 2015 Nobel Prize for her discoveries concerning a novel therapy against malaria?
Yeah, this is the familiar one to me. May I give a hint?
Please go ahead.
So the scientists come from the Asian country.
Correct answer is Tu Youyou.
She's a Chinese scientist.
The 11th question is, in Greek mythology, which creature flew too close to the sun?
Oh.
Indeed, I see the majority have got this right. It is Icarus. The 12th question, Salk is to IPV as Sabin is to OPV. I see a lot of people know this question. And finally, the last question. In 1993, the Nobel Peace Prize was jointly awarded to Frederick William de Klerk and which other prominent figure? And the final answer is Nelson Mandela. So now we will play our final game, and I hope all of you have kept a record of your answers, as it will assist you in the final task.
Yeah.
And we'd like to congratulate Tamiris and Rajinda for scoring quite highly on this quiz.
Congratulations.
So using the first letter.
Yeah, please go ahead.
Thank you, Wendy. So using the first letter of your answers in the quiz, type in the word that describes the theme of the DCVMN and BioVax 22nd Annual General Meeting.
Shall we invite everyone to type in the chat window, or you can open the unmute part?
Yes, if you haven't joined the Slido, I think in the chat will be just as good.
Yeah. Oh. Okay.
I'll give members just 30 seconds more, and I'll hand over to you, Wendy.
Yeah, thank you, Spartan, for the host of the games. And I think everyone knows now the answer. The theme of DCVMN and BioVax 22nd AGM is the word collaboration, especially in the background of the COVID-19 pandemic that stopped everyone to meeting together, discussion and communication closely. But the collaboration is even more important at this moment to allow us to fight against the disease, protect every people and person in the world, to bring healthy and welfare to people. So today The next would be the special session, and we not for this DCVMM meeting, we not yet have not only have our manufacturing, our stakeholders in public health field, but we also have many partners from different views to supporting the findings against that COVID-19. So today we have so many manufacturers, suppliers also join our meetings. So the first of all, I would like to introduce the first speaker, Mrs. Josephine Chen. She's a senior consultant and from the commodities APAC Merck Kaga Ways Forward. She will provide a presentation and ways forward future vaccine manufacturing. So welcome.
Okay, thank you so much. Thank you so much, Mrs. Huang. And can you confirm that you can see me and can hear me?
Yes, I can see that. Perfect.
Okay, so yes, thank you again, and we are very grateful for DCVMM to give us this opportunity this year. Okay, and then to really have the 10-minute time slot to discuss with you. And so I put it in the way that just put the title and then just be very straightforward how Merck can help you in evolving the vaccine manufacturing. Yeah. Okay. So the content I want to share with you are some of the trends that we observe or where we think the vaccine manufacturing is going towards. And then a second part is the cases. So we hope to share with you some interesting cases about this collaboration that we've always been doing. So what are some of the outcome of our collaboration cases, and that hopefully to also give you some thoughts on the possibilities. And then third, I would conclude with our holistic offering from our portfolio to show you what kind of capabilities we have. And so the trends, the cases, the capabilities. Okay, so first, just to share with you some of these, some of the perspectives that we think. So Industry 4.0 was being brought up a couple of years ago, and then to leverage it into the bioprocessing, it's really to embrace, like how to embrace this digitalization into our vaccine manufacturing or bioprocess manufacturing. And with COVID, right, COVID has changed so many things in our daily life, including this beautiful virtual conference that we are having right now. So it really accelerated this Industry 4.0, or we say bioprocessing 4.0, and with all the CMO demand or the global vaccine demand, the CMO partnerships, the licensing partners, people are trying to repurpose the existing manufacturing capacity into this COVID vaccine manufacturing. We want to quickly adapt our processes to the COVID vaccine manufacturing processes. And also we are discussing how, what are we gonna do when the COVID becomes endemic, which is very possible. And then this extra capacity left, what are we going to do with it, right? So all this really pushes us to think about this agile vaccine manufacturing, and or we say new ways of working. And with that, we want to show you also in a visual pictures how the vaccine factory transformation has been happening. So in the legacy time, or maybe we're still very familiar with all these standard steel tanks and pipings, and so it's large floor space and clean rooms. It's with complex piping, and you can imagine all the time and labor would need to be put in the preparation and also the afterwards cleaning and also the validation. Okay. So in 2020, they started to have these smaller clean rooms that incorporated in this single-use consumables and systems, and you see that reduced floor plan for these overall facility, and it's a bit simpler structure. And nowadays, the new facility generation, we wanted to have this more open room concept for multi-products. It's and working towards the closed smarter processes, where we think in the upcoming future, we will see these even more compact, so ultra compact and very modular little cells put into this open space, because it's fully closed and fully integrated with digital technologies, from recording, data collection to quality control or data analysis. Right? So that is a future way that we are expecting on the first facility perspective. Okay, so on the other hand, if we look at the purification process itself, we see the trend in moving towards the platform technology. So very easy platform technology is moving from the traditional vaccine that we designed the process around, process its product, to now we have a platform that serves for multiple products. Okay, so and that is feasible, especially in the modern vaccine modalities, for example, recombinant and viral vector to mRNA, plasmid DNA. It gives a perspective of improved biosafety, not only for the product to eliminate the outside contamination, and also from the risk to the operator being infected by the pathogen, right? Okay, so to summarize the benefits of this templated platform, we really say it supports the bioprocess standardization, and you can imagine it reduced the process development time, reduce the changes that you have to do for different processes, and then the easier regulatory approval way to go through. Yeah, so this is really the trend, and we work with customers to move into this direction. So another trend is this really the flexible. So the flexible manufacturing or flexible factory is really integrating the single-use technologies to these digital modular designs, right? In order to simplify the process and give smaller footprint and give this modular digital controlled centralized orchestrated manufacturing processes. So those were some of the trends. So like from the platform technology to the incorporation of single use to a more flexible closed processes, and with the multi-product ballroom design, right? And then I moved to some of the interesting cases. I will just be quick because of the time. And I want to share with you some of the possible ways of collaboration with a supplier. Like we did a design project with the partner from 6 international organizations to develop this one-step affinity chromatography. So this can greatly reduce from the traditional multi-step vaccine manufacturing processes. And then with another case is with Jenner Institute, that we had the collaboration to develop a rabies vaccine candidate and then make into fully single-use and GMP compliant. And last year, they used 2 months' time to develop the COVID vaccine out of this original rabies adenovirus vector platform. And that is the famous AstraZeneca vaccine COVID vaccine nowadays. Another case that we wanted to share with you is the collaboration with Baylor College of Medicine. This is originally from the Merck mission with the WHO to eliminate the tropical disease schistosomiasis. And then we developed this, we helped to optimize the yeast-based recombinant protein purification platform into a single linked microfiltration together with ultrafiltration. So anyway, they use this yeast-based platform to develop also last year in the receptor binding domain recombinant protein COVID-19 vaccines, and is going to be launched very soon by the licensing partner Biological E. So, and then finally, the last case I wanted to share with you is what we also had the collaboration with the Middle East for vaccines in Egypt to help them to optimize their process in foot and mouth disease for animal health. So we optimize quite several steps, including the media filtration, clarification of the cell debris, ultrafiltration, and finally the adjuvant filtration. We reduced from 11 stereo filters to just 1 stereo filter. Yeah. So you can imagine all the cost savings that we were able to achieve. Okay, so finally the capabilities. So we really look forward the collaboration together with our customers. So from development to implementation, we do whatever we can do, and we participate in all sorts of okay. And then, so basically we helped in the following cases. I summarize here in the last slide because this is really the process development we help in the scaling up process to make sure the smooth transition or the tech transfer. We help in all kinds of testing service or development service or CDMO services, or we help in the facility design from, so we have a end-to-end capability, also be able to help supporting this and partner with the engineering company. And we also help the customer to set up the quality management system. So in all perspective, from upstream to downstream, from pre-discussion to training. This is all what we can offer to, and hopefully to help to advance the vaccine manufacturing altogether. So thank you very much for listening. So that's my presentation today. Thanks.
Thank you very much, Ms. Chen, for this great presentation. Any question? Oh, okay. I will leave the Q&A to the last. So the next time we hand over the presentation to Mr. Tong Shi. He's the business development manager from Toflon. Welcome.
Good morning, everyone. Thank you for your time. Today, I'm going to.
I guess we cannot see you. Can you open your video?
Okay.
Okay, great.
Is that okay? Okay.
Yes, please go ahead.
So today, especially, I'm going to share you about Toflon and the case study, especially for the COVID-19 done by Toflon. Okay. Today, my topic that Toflon-based practice for human vaccine. First one, I'm going to share you what is the Toflon. Toflon that we have 28 years experience in pharmaceutical and 45 countries abroad that was using our customer. And also we have more than 1,400 patents with our technology. And we have more than 2,500 pharmaceutical customers and more than 10,000 equipment and the systems already installation worldwide. This is Doflo. And our vision that was especially for smart pharmaceutical factory building. And our innovation that was from drug developing to drug manufacturing. So generally for biosimilar, especially for vaccine, we can do the engineering as well as the drug substance and drug product. So for engineering, we can provide the concept design, basic design, detailed design, process design, as well as a clean room and project management. This is our EPC ability. And for the bioengineering, we can provide customer both stainless steel bioreactors as well as single-use bioreactor system, as well as down process for chromatic system, filtration system, and or the major preparation and buffer preparation system. For this stainless steel system, also we provide the CIP, SIP skid, and for the bulk, we also provide the freezing and sort equipment. So generally for all this process, we have the inactivation system, especially for the all the wastewater doing inactivation. And for drug products equipment, we can provide from the formulation, preparation, with to the secondary packing. That will include the aseptic washing system, sterilization, filling, both for vials and PFAS, as well as the closed system isolator. We also provide the automatic loading unloading system and our lactation system. After that, also we provide the automation inspection as well as the pressure decay for the check the leakage of the virus. So all these systems that we mostly cover the engineering for vaccine manufacture. Meanwhile, for the single-use system and the consumers, we have different kind of single-use system, such as the circulation bioreactors, major buffer preparation, freezing zone bags, and aseptic transfer and harvest bag system, and as well as the bag filling. This is our single-use bag system. Especially for this COVID-19 vaccine, we support customer to do the product rapidly into the market. This is one contribution during the COVID-19. Another product that was in our consumers' ability for the reagent, including the media, DMSO, recombinant protein, CRISPR solution, and other kind of nucleus. So for Sulurin, that was especially for the down process chromatic system, we can provide all this a type of reason for purification. And for filtration system, we also provide this type of feature and members for sterilization filtration, ultra filtration, viral remove filtration, as well as the DF filtration. This is the generally for the consumers. For Doflo, another core business is our tradition injectable business. So especially for the cool fill system, Doflo innovation solution that we can provide the process scale up and technology transfer, advantage drug manufacturing and next generation drug manufacturing. And the second part, Dongflong innovation for vaccine manufacture. We can share you. This is a general impression of Dongflong from DS, DP, and whatever the engineering. So all this scope we can integrate in one system for customer to building a new facility for vaccine. And our integrate solution was from the back process. We can start design the factory layout, mass balance, and the process flow diagram, as well the PID and the 3D configuration, and then here the system finish. So for the DS system, we can design from the green line, start from the bioprocess. And for Cool system, both we can provide the freezing dryer, automatic loading unloading system, isolator, and the automation solution preparation system, as well as the aseptic feeding line. So this is generally our Cool system. What advantage for Cool system is oven. That was especially for CGMP compliance, module building interface, automation, and isolation system. That was system generation, and for the module equipment expandable facility and module technology. That was in our EPC delivery project. The last part I'm going to share you during last years, we have building many COVID-19 case study that was especially support customer manufacturing the COVID-19 vaccine, including different type of technology use. First one that was especially contribute for CMBG. This is also largest vaccine, COVID-19 inactive vaccine in China. So we have contributed totally 4 phases, from phase 1 to phase 4, generally for the preparation system, and for major preparation, buffer preparation, protect harvest. So totally all these vessels that was provided by Dongflong. And this is a general layout for phase 1 we have done. This also CMBG, and the CMBG is in another facility. The second technology route that was Adenovirus vector vaccine. This project is a thank-you project from the DC, DS to the DP. Our strength for this project that was generally in one-stop shop. So for this project, we provide all this single-use system and DP drug filling line and packing line. This is generally for this Fast 3 project. We had provide this integrate solution with a multiply platform. So due to this single use is very flexible. So in the future, also this facility that considered about for another type of recombinant protein vaccine. And the disposable system or have a large scale application unit project, as well as consumables from Dongflong. This is a site pictures. We had finished the installation upstreams, downstreams, as well as the feeding line. These are also general pictures from the site we have delivered last year. The last case study that was especially for the recombinant protein vaccine in China. This is also have good results in clinical results in phase 3. So this project, firstly, we done this project with the output $100 million per year. That was we established all these projects in 4 months. So from the upstreams to the downstreams, as well as the filling line and the secondary packing. So this is generally a layout for this facility, and for all this drug substance equipment is provided by Dongfeng, as well as the drug products filling line, as well as the inspection, pressure decay, and cartooning, as well as the secondary packing for the pallet packing. Now you see is some pictures from the site, as well as the cell culture zone. This is the 3 stainless steel barricades that was for the insect cells. Probation vessels that was especially for the major probation, and for down process we also provide the ultrafiltration system, the hollow fiber, as well as the definite filtration. And the commercial system we also provide in this facility for purification tool, and the probation system in formulation zone. And for the bulk bar washing and sterilization room, as well as the filling zone. The second pictures also you can see that was especially for inspection and leakage detection and the labeling, cartooning, as well as the pallet packing. So for this case, that was a complete EPC project, including the utility equipment, the core drug substance equipment, drug product equipments, and the clean room air handling unit. So that was complete by done by Dongfeng, and we delivered this project and complete in 6 months. Thank you all. Thank you, everyone.
Thank you. Thank you very much to Mr. Shi for the presentation and introduction of Dongfeng's capability advantage, and especially the contribution and COVID-19 project. Thank you. And the next, we invite my pleasure to introduce Dr. Vibin Jessup. It's the Executive Director of Nobel, and to give us the presentation. Thank you. Please. So Dr. Vibin, you may share your slide. Yes.
Yeah, so can you see the slide now?
Yes, perfect. Please go ahead.
Yes, so thank you. Thank you, Ms. Wang. And I'll try and be as close to the time limit as possible. So today I will speak about the Bayesian approach to enabling vaccine manufacturing ramp up. And ramping up is extremely important in the current COVID climate that we are in. And how do I say it is important? So if I were to illustrate the importance of ramping up vaccine manufacturing at this critical juncture, it is because, as many of you have highlighted in the earlier presentations, the pandemic really transformed the global vaccine production. If I were to kind of give you this graph, you can actually see here that about 9.5 billion doses of COVID vaccines is what will be manufactured in 2021. Now, this is about twice the volume of the normally 5 billion vaccine doses across all the different vaccine types that you tended to manufacture before the pre-COVID era. And yet that is actually still shorter than the 11.5 billion doses of vaccines that you will need to immunize the entire global population. Now, COVID vaccines, as all of you do agree, is extremely efficacious. It is extremely effective. And unvaccinated people, according to Public Health England here, in the diagram above, has been shown to be 7 times more likely to test positive if you're unvaccinated, 49 times more likely to be hospitalized, and 32 times more likely to die. So it's extremely important that we do focus on the COVID vaccines, no doubts about it. But yet at the same time, we also have to focus on the other vaccines. So all these different diseases, say hepatitis B, diphtheria, tetanus, you name it, you have a declining trend here simply because of a massive immunization scheme that's been going on for several years. So it's extremely important that we focus on these vaccines as well. Now we have to focus on COVID vaccines, we have to focus on the other vaccines as well. And the only way we can do that is to ramp up the vaccine production. Now, ramping up the vaccine production has a lot of challenges. Now, those challenges are primarily because of the complexities and the variances in the different manufacturing processes of the different types of vaccines. So one size that fits all approach will not be applicable for all the different vaccine types. So vaccine types is predominant. I mean, as many of you did highlight here, so be it from the live attenuated to the nucleic acid vaccine. I'll be very brief here. So if you look at the infrastructure that you would require for live attenuated, it's a BSL-3. If you look at nucleic acid, it's typically a BSL-1 or a BSL-2. So right from the variances there to including a cell line, be it cell culture, be it microbial, be it the CHO cell lines, be it the Vero, be it the insect cells, all these variances will actually create a bit of a problem from a manufacturing supplier's perspective, like us. And of course, you've got the strategic considerations, which is largely based on the engineering triad limitations, which is the cost, customization, and time. And as all of you will agree that there's a lot of tension with all these three variables of cost, customization, and time. And what we've done with Biozine is we've evolved upon this model and looked at this need-based tailored customization, whose objective is to accelerate the speed, reduce the cost, and increase the flexibility and customization. Now, this is applicable for the current plants that is actually there. So if you apply this model to a facility enhancement, you will actually see a 100% customization, except for a centrifugation or the chromatography columns. If you're looking at repurposing the existing facilities, right from retrofitting the existing hardware and the software and the DCS systems with process analytical technologies and process sequence changes, yes, we can do that all. Yet at the same time, we have also looked at and evolved upon the BZ tracks. Now, this is specifically for the new facilities, wherein the focus for us is to accelerate the speed and reduce the cost. So here, if we apply the BZ tracks model and our product portfolio to the greenfield facility, the design and build is more in a modular fashion. It's in a semi-knockdown architectural pattern that we actually follow. We're looking at smaller and more production plants. Now, this is typically more applicable for the mRNA vaccines. And we also have the build, operate, transfer model with a lot of collaborative approach, as a lot of you have highlighted in the previous presentation as well. So how do we do this? We actually do this because we leverage upon our core competencies in design and build, which manufacture the different equipments. We look at the automation services right from the DCS and PLC orientations to bioprocess engineering to regulatory and validation services, training and facility integration services. So we use all these skills and then try and learn a lot more about the product, and then finally translate that product knowledge into process support and production support for the vaccine customer. Now here, I do have a quick collage of a couple of pictures that we have done, which are the automated bioprocess plants and technologies, which is under the DCS platform. And here we have actually designed it, we have manufactured it, we have installed it and commissioned it all during the COVID restriction time. And if I were to see the track record that we actually have during the pandemic restrictions, we were completely working all the time. So when the world was sleeping, we were actually literally working. So 24/7, 365 days, and 7 COVID vaccine manufacturers is what we're working right now in 6 different countries. And during this period of the pandemic restrictions, we have supplied 179 groups of equipment to Brazil, China, India, the Middle East, the South Korea, Switzerland, and Thailand. At the same time, we've also conducted 26 physical factory acceptance tests with all the COVID bubbles and the daily RT-PCR testing. We've also conducted 20 online tests with all the visual technologies in 4K, et cetera, et cetera, et cetera. We've installed and commissioned 23 projects during this time. We've executed every single project on time and to quality. And with that, I do feel that we're pushing the frontiers of vaccine production. And with that, I will actually keep it short and say a thank you. And my closing message would be, just as we focus on the COVID vaccines, let us please also focus on our children. I think that's important. Thank you very much. Ms. Huang?
Thank you very much, Dr. Vivian, for the great
Ms. Huang?
presentation. And yes, can you hear me?
Yeah. I mean, I just lost you. So I was just thinking I've kept to the time. I mean, it's just 5 minutes for me. So yeah.
Great presentation. Thank you very much. So I think these great cases to illustrate the collaboration and how to help each other unite together to fighting against COVID-19. Thank you. So the next, I would like to, and thank you very much, Dr. Wibing. For the next, I would like to invite Ms. Stephanie Craig. Yes. To share her presentation. Ms. Stephanie is the process engineer from Bioengineering AG. So please go ahead. Thank you.
Thank you. So your host will share my slide. Yes. You can go directly to the next page. Yes, hello everybody. My name is Stephanie. I work for bioengineering since more than 5 years, and it's a pleasure to be here and to talk about some experiences in adapting existing plants to new requirements. Bioengineering is a supplier of complete upstream bioreactor systems, from research to full commercial production scale. We design, engineer, automate, manufacture, and install plants, and we offer commissioning and qualification all from one source. Some of you may already know our company. We have worked with many DCVMN members, and nearly 25 of all our projects since the past 50 years have been for vaccine production. The pandemic during the last 2 years has brought a lot of opportunities, but also challenges. For example, the dependence and long waiting times on single-use consumables or export restrictions. So those with existing stainless steel plants have the advantage to immediately make a few minor changes in order to ramp up production capacity in a very short time. Next 2 pages, please. There are many different ways we can help you with this. I would like to talk in these 5 minutes about 2 recent examples. One possibility is to increase the production volume. By increasing the working volume by 20%, the harvest of the end product is higher accordingly. To maintain the same conditions in the bioreactor, we need to recalculate especially the heat transfer, aeration rate, and agitation. As you can see in the picture, the heating or cooling jacket is optimally designed to the working volume, and if this is higher, the upper part of the culture is not covered anymore. That's why we need a higher heat transfer rate. Also, pipe and agitator dimensions are specifically designed for the requirement of the former working volume. Not to forget the overfill protection. In our example, it was a hydrostatic pressure probe. Oh, not yet. Go back again, please. Thank you. Which was covered by the medium and didn't work anymore. And also the overfill protection is related to automated safety functions, which would be a problem with just fill more in the bioreactor. So as you can see, we changed some critical process parameters, and That's why we had to revalidate customers' processes. And on this aspect, we highly recommend to involve the responsibles for quality assurance from the beginning on. Now we can go to the second example. Next page, please. Another project we worked on had the goal of increasing the cell density and shortening batch duration, which increases efficiency, product yield, and profitability. The approach of high cell density can be achieved easily by an external perfusion system without adaptations at the vessel. Instead of steps with 1:10 ratio, it is possible to go directly from pre-seed to production vessel with a ratio up to 1:50. Although a higher cell density has impact on the physical characteristics of the culture, like viscosity, heat transfer again, and also for this option, it is required to recalculate the equipment and to revalidate the process. But with this approach, customers can save time by removing one bioreactor size in the production train and also increase the production volume by reusing the middle-sized bioreactor as an additional production bioreactor. So if you now are looking to optimize your production output or are interested in more ways we can support you with your vaccine plant, you can contact me or our team at our virtual booth. Yes, that was my presentation. I thank you for your attention.
Thank you very much for the great presentation. Thank you, Ms. Stephanie, and thank you for company to bring a solution to the industry. So I would like to welcome the next speakers, Dr. Andres Castan. He's the Strategic Technology Partnership Leader from Sativa. Welcome.
Thank you very much, Wendy, for the kind introduction and for inviting me and giving me the opportunity to speak today about flexible approaches to address modern vaccine demand. A crisis is often a good driver for change, and with the urgency of the COVID-19, we have found new ways to accelerate development times, like setting new standards for collaboration between academia, big pharma, vendors, and regulators, finding new paradigms for parallel development in clinical trials and taking more risks, but also investing in manufacturing capacity. We have seen how the long research of more than 20 years paid off in the development of developing mRNA and viral vector vaccines. And finally, we have seen the need to increase the manufacturing capacity and localize manufacturing locally in different countries. I want to have a look at the challenges related to mRNA manufacturing, looking at the distributed process that is seen in many projects, where the plasmid manufacturing is on one side, the mRNA manufacturing is on one side, and the encapsulation and filling is on one side. And the reason is that few manufacturers are actually equipped to work with all parts of the process. And this distributed process leads to bottlenecks in logistics and supply chain. And many suppliers use kind of repurposed equipment or home-built solutions to work with these processes. And that really triggered us to map different processes and get an overview. And this is a little bit of the results where we have looked into different modalities from mRNA different viral vectors, plasmid DNA, and of course, maps, together with industry experts, our customers, and SMEs, and have created optimized workflows, including our equipment together with PAL equipment, but also new acquisitions like Vanrex for fill finish and PNI for encapsulation of mRNA. So with this toolbox, we are able to support our customers end to end for a vast number of modalities, a number of processes. But let's look deeper into the mRNA workflow and start with plasmid manufacturing. To give you an example of how we map the processes, you're starting with the fermentation process down to the downstream. And in this example, it's a 50-liter E. coli fermentation. You get some ideas about the output. But what we are putting in place are two types of solutions. One is what we call the Flex Factory, which is a manufacturing line with the equipment, with the consumable supports, and with an automation solution, which I will describe later on a little bit. And the other flavor is a facility or built of modules that you put in a shell building, which we call the QBio box, which is pretty flexible and will kind of supply you both with the Flex Factory and the facility. The Flex Factory offers also is also offered for mRNA, and again you see the process mapping. Get some impression about the output, but for us most important is really the flexibility to adapt to different scenarios, both when it comes to titer and yields. And again, we have the manufacturing line, the Flex Factory, and the facility, which can also include both the media prep and even the encapsulation and the filling space. Since mRNA is a cell-free process and the product is sensitive to degradation, it might be beneficial to start manufacturing in a space that is not previously used for cell-based production, and here also the QBio would be of good use. I said flexibility is really a key concept, and I think it's important to map the needs and model the different manufacturing scenarios in order to meet your manufacturing goals. And with that, you can ensure that you have the right size equipment and choose between scaling up using different equipment, like here, for example, the wave or a stir tank bioreactor, or scaling out by having multiple units of the same equipment in the process. Single use is actually a choice that facilitates flexibility. For example, with the wave system here, you can choose different disposables to scale up. The same is true for chromatography systems, where you can choose a different flow path that actually matches the size of the product you are running. Same is true for the filtration equipment, for example. As I said, automation is really important, and in this whole offering, and in the example of the mRNA process that I showed earlier, that there is a kind of central historian where process data from all unit operations are stored. or this is built with standard industrial components, for example, for backup and whatever, in order to create an end-to-end solution. So you do not have to go to a system integrator to tie together all the unit operations, or you do not need either to build a large automation team. I talked a lot about mRNA manufacturing, but we also, of course, as I showed you in the earlier slides, have off-the-shelf process solutions for other modalities. In this case, an AAV process. Again, you see the process flow from the inoculum to the bulk harvest. In this example, it's a 200-liter fed batch process in HEC293 cells, which is transiently triple transfected. You get again an idea about the virus titers that can be produced. Our flavor of the manufacturing line, the flex factory, and the facility solution, which will be designed in biosafety level 2, which I think is important to point out in this context. Finally, I want to conclude and saying that I hope I have shown you facility and manufacturing line solutions that support different modalities, that we have pre-designed manufacturing lines based on the most current process understanding, and that will help to build capacity quickly, to de-risk both the cost and the timelines, and get and get our customers up and running as fast as possible, and accelerate timelines and speed to market. So with that, I want to thank you for tuning in today. And if you have questions, please reach out to me in the chat or Q&A session, or shoot an email. I'm happy to answer your questions. Thank you very much.
Thank you. Thank you very much for Dr. Castan for a great presentation and the illustration of the manufacturing industry's solution based on mRNA cases. Very clear. Thank you. So the next, I would like to invite the last speaker of this session, Mr. Christian Ronda. He's the Global Product Manager and Sales Director from Centennial. So please go ahead.
Thank you very much for the opportunity to be with you today. I would like to do two things in the short time that we have today. Give a little bit of a nice overview of what Syntegon, who Syntegon is, and what we do, and I have a little video for that. And then what our capabilities are and what we can provide to contribute to the industry in regular vaccine manufacturing, and of course, in response to the pandemic as well. Take a look.
We at Syntegon know that our performance is the key to your success. So let the numbers speak for themselves. 64,000 machines installed and running in 140 countries. Leading in more than 30 segments of the pharmaceutical and food industry. Your reliable partner for standalone machines, systems, and services in 30 locations around the globe. (1,100 service experts worldwide. 1.3 billion euros total revenue. More than 2,000 registered patents ensure intelligent and sustainable technologies. "150 years of experience. "6,100 passionate employees. With one mission. Processing and packaging for a better life." Syntegon, processing and packaging.
So thank you for taking a look at that. Syntegon may be a new name for some of the audience members at the DCVMN. It's relatively new. We were formerly known as Bosch's packaging division. So we have been rebranded and refocused to serve, and then primarily here today, the pharmaceutical industry. So I'd like to give a brief overview of what we bring to the table, what our capabilities are, and how we contribute to the vaccine manufacturing infrastructure globally. So we are organized in different business groups, process technology groups, then liquid and solid dosage form packaging, together with inspection technology, and then also medical device assembly. When you think of a traditional manufacturing chain, the different steps for a typical liquid product, like most vaccines are, we have upstream operations where we provide media and buffer systems together with bioreactors and fermenters. We also have process systems, including cleaning in place and sterilization in place systems for entire factory solutions, together with formulation systems for small volume and large volume peripherals, together with storage, and supporting the entire factory infrastructure as well, all the central pure media systems that are required, from pre-treatment and pure water solutions to pure steam, water for injection generated hot or cold, and then storage and distribution of that pure media as well. That all comes from our processing center of competence here in Germany, in Dresden, where I'm coming live to you today from. And we also have, from our Austrian Center of Competency, we have part sterilization service the entire manufacturing chain as well, together with terminal sterilization for other products that require it, and now also freeze drying as well, which is a new addition to our portfolio. We're proud to launch and to raise awareness of that this is now an integrated capability for our portfolio as well. Following that, we also have filling and inspection, filling for all packaging dosage forms, together with closing, and then the associated inspection that comes after that. Primarily, we are Euro-based, and most of our centers of competency in Germany, but most of these equipment is also manufactured and serviced, certainly serviced and supported from locations all over the world. And something that we like to stress is that in delivering complete turnkey solutions comprising most of these solutions in combination, we really pride ourselves in the thoroughness in the development and the ready deployment of the interfaces between these systems. If that is not a central focus of a portfolio offering like this, then our customers are not able to really leverage being able to do one-stop shopping, which in this day and age is critical for accelerating project execution timelines. One of the examples of system integration here, just to show an example, is between formulation and final fill. So the clear benefits of an integrated solution are an optimized plant layout from the get-go, with all the associated pipe routing and the material flow designed around that, coordinated processes, including the alarm functions, being able to monitor the process from any one of the human-machine interface points around the line, and then also significant cost savings when there are shared peripherals that can be shared between more than one station. And in this particular case, the example would be clean in place and steam in place solutions. We have substantial benefits that come from that as well. So better yields with a smaller footprint, which saves money. That adds to the overall smaller capital investment with lower risk that goes associated with that. And since everything's delivered from one hand, supported by the same team, faster project execution with better comprehensive support. And in this case, it really can be seen that flexibility, faster project execution, and being able to deliver on time and reduce risk really don't work against each other and are not trade-offs that need to be made. This is something that that reinforces itself and that can benefit our customers. Here's an example of a project that was delivered earlier this summer for a multi-vaccine manufacturing customer, and the critical value add for us in this particular project, which I'd like to highlight today, is the modularity built into the equipment itself and the purpose that can serve for our customers. Of course, as covered by a couple of previous presenters, flexibility in the building itself and the facility is critical, and it's been wonderful to see the great advances that have come in flexibility in the manufacturing infrastructure from a facility perspective. But for us, from our perspective, there's also great benefit in modularity in the units themselves, so that you can build in flexibility at the equipment level, regardless of the product mix that a particular customer may have. So that is a central aspect of our upstream equipment with bioreactors and fermenters, and then with our formulation equipment as well, building in the flexibility into these systems, just hardware-wise, but controls, documentation, qualification, supporting services, so that the facility can fully leverage this equipment for the full range of products that might go through it, responding to demand flexibly. So with that, I'd like to thank you very much for the opportunity to introduce Syntegon to some of you, remind the rest of our capabilities, and we look forward to hearing from you on any specific applications where we might be able to make a contribution. Thank you.
Thank you very much, Mr. Ronda, and the introduction to the Syntegon. I believe with your presentation, more people will know more about your company and your capabilities. Unfortunately, I'd like to more discussion, but unfortunately, this is the end of the session. We have running over time. So in case any questions and discussions and communications in need, we can move on to the exhibition hall and seeking the communication with the speakers. Thank you very much for the participation. So I'd like to announce the end of the session. Thank you. Bye-bye.
Thank you. Bye-bye.